Hi, my name is Xavier Torregrosa Jorques, and in this video I will talk about AI agent orchestration with Conductor and Claude Code. In traditional software development, engineers work on new apps, features, and other type of projects in a sequential way, meaning that if, for example, a project is divided in 3 tasks, we will start working with each task one after the other, meaning that if an engineer starts with the first one, he or she will be blocked from starting the next 2 until the first one is completed. This can be solved by adding other engineers to the project, so those tasks can be started simultaneously and save development time, although this has the eventual cost in resources and adds an extra layer of complexity because of the necessary communication between those engineers to be in sync with the specs and designs that they share. With the introduction of AI agents like Claude Code, engineers can save development time, reduce communication cost, and simplify complexity by orchestrating an unlimited amount of coding agents in our projects. So one engineer can set up many agents as required to work in individual tasks in parallel. Let's see an example of how this will work in real life. For this demo, we will develop an AI assistant type of chat workflow. We have a sample design of what we want and some specs about the required functionality. For this demo, we will keep it simple and we will use mocked AI responses and local storage for the chat workflow states with Sustand. To orchestrate all the Claude Code agents that we will require to develop this app, we will use Conductor, a graphical interface tool to manage the execution in parallel of AI agents. As a first step, we will set up the context for the future AI agents that we will require. To achieve this, we will create a new workspace in Conductor and write a prompt for our AI agent to generate the documentation in the format of empty files from the specs and designs in a language that our AI agents can understand, as well as referencing the provided designs. This will help to educate our agents about what we will require for this feature, as Workspace and Conductor do not share context, memory, or chats within each other. Therefore, we have to reference the specs and designs when running prompts in our agents. All of these files will be added to the repository in case we require them in the future, or simply other engineers start working on this repository as well. These generated files are not static and can evolve whenever the spec or designs are updated. Alternatively, Jira, GitHub, or linear issues can be referenced instead of writing the entire documentation. This will require to configure Claude to connect to the required Jira or linear MCPs. But the advantage is that our agents will be in sync with the latest spec definitions and designs that our team will be working on. After the files are generated and added to the repository, we will ask Conductor to remember them so we can easily reference them in our future chats with the AI agents. Claude Code will memorize the generated documents and then reference the designs by copying them to an internal folder that Conductor knows. We push everything to our remote feature branch and create a PR so another engineer or AI agent reviews the code. Before doing so, we can ask Claude Code to review our changes in order to spot possible defects, bad patterns, or any other kind of issues. After the PR is reviewed and approved, we can merge the feature branch to our main branch and archive the workspace, since we won't be needing it anymore. For the next step, we will divide the project into different tasks that we can build in parallel with our AI agents. We will divide the different components in 5 different tasks, one for each UI component. All components developed will be pure UI components so we can build the logic separately. There will be another simple and small task to create the layout of the app. We will be working on this one first, so let's start by creating a new workspace in Conductor and ask to build the layout as specified in the designs and specs. We will ask the agent not to develop any component yet and just leave some text placeholders where the future components should be rendered. The reason for starting with this task first is that we will use the initial layout as a test page, so we can visualize and verify the output of each agent immediately. We could build the layout in parallel as well with the other tasks, but it will be difficult to test and validate the output from each task unless we create storybooks for those. To simplify this demonstration, I will just test them directly in the layout. So, after our AI agent has finished building the layout, we run the workspace and check that everything is in place. Once the layout is ready, we will create workspaces for each task and ask the AI agents to build specific pure UI components based on the specs and designs that Conductor memorized. Those agents will generate the code in parallel, and as soon as they finish, we can review their output by reviewing the generated code and by running each workspace independently. If we are happy, we create a PR for that workspace and move on to the next one. As soon as our PRs are approved, we can merge them to the main branch. We will likely encounter merge conflicts when merging sequentially, but this should be minimal as there shouldn't be much friction between workspaces. This should be easy to resolve by Claude Code itself. Once the PRs are merged, we can archive the workspaces. Merging and archiving workspaces can be done independently from each workspace as soon as possible, meaning we don't have to wait on the other agents to finish any task. As a final task, we will wire all UI components with the logic that has already been implemented. This prompt can probably be as simple as wire everything, as at this point Claude Code will have enough context to know what to do. But I will make sure it follows the initial specs and designs just in case. Now that everything is wired up, we run our final workspace one last time to check that everything works as specified in the specs and designs. Agent parallelization doesn't have to be done through workspaces. If we have small tasks such as bug fixes, improvements, refinements, refactoring, we can open independent chats under the same workspace and run small tasks in parallel without having to create an entire workspace for each. In this example, I will open 3 different chats to add a help button, a resizable column, and a delete button. I will wait for the 3 of them to finish and then rerun the workspace to verify these changes. And that's how we orchestrate project development with parallel agents on Conductor with Claude Code. I hope you like this video.